guys, so today we're going to be doing the surface area of a cylinder. So we're on page 620 in your workbooks. Make sure that you follow along. You all sent me some great pictures of some cylinders that you have in your house. I saw a lot of water bottles. This is actually my water bottle at the moment, but I saw a lot of really cool things. Some candles, that sort of thing. What I have right here is an actual cylinder as well, and there's some vocabulary words that you kind of need to know as far as cylinders are concerned, okay? First of all, on a cylinder, the circle is what's called the base, okay? This is a base, and this cylinder happens to have two bases, and so this is also a base. Okay, now what do we call this side right here? This side right here, we actually call the lateral side or the lateral area. Okay, and so what's really cool about this object that I have right here is that I can take it apart and I can take out what would be essentially wrapped around this cylinder, okay? So if we wrapped that cylinder up with wrapping paper, this is what it would look like. It would look like a gigantic divided by sign. But this part that's right here was the part that was wrapped around on the inside of my cylinder. And so remember, the circles are called bases, and then this is what's called the lateral area, okay? And so that's what this whole page is basically telling you. So I just wanted to show you again, this is the actual surface area of the cylinder. So if I fold this back up and put it back together again, I'm going to have an actual cylinder. This is what we call a net, because if you unfold it and make it a two-dimensional shape, you get what is called a net, okay? And this particular net shows us what a cylinder would look like. So the one thing that I wanted to show you really quickly, if you take a look down here, it says the lateral area. Remember, that's this rectangle, okay? The rectangle is the lateral area. And you know how to find the area of a rectangle. Remember, it's just length times width. Well, here's the part that's different as far as the cylinder is concerned, okay? The length ends up being the part that would get wrapped around the circle. And when it wraps around the circle and goes from one side all the way around, that's the circumference of the circle. And so that's 2 pi r. And then the width of the rectangle ends up being the height of your cylinder. So if I can get this thing back in here, you can see the width of that rectangle is just the height of my cylinder, okay? And so the lateral area for the surface area of a cylinder, the lateral area, just this rectangle, is going to be 2 pi r h. Now the total surface area is going to take and add the rectangle and the two bases. Well, how do you find the area of a circle? Remember, it's pi r squared, okay? And since there are two of them, we're going to multiply it by 2. And so the surface area becomes the sum of both of them. So here's the two bases for the two circles. And then here's the lateral area. So this is a long formula, but that's where it comes from. Now, do you have to have this memorized? Good pajizama pizza? No, okay, absolutely not, okay. Let's go try a couple of examples, though, and take a look to see what you have to do. So let's go look up here at the top. Example number 1, okay. We need to find the surface area of this cylinder. So notice they wrote that formula down that we just came up with down at the bottom. So 2 pi r h, this is going to be the rectangular part or the lateral area. That's that new word that we just came up with. And then 2 pi r squared. These are the area of the bases, okay? And remember, there's two of them. There's a circle on the top and a circle on the bottom. So it's just a matter of plugging things in and seeing what you get, okay? So let's go ahead and try letter A and see what happens. So it doesn't matter what order that you do it in, just keep in mind we need to do 2 pi RH, okay, plus 2 pi r squared. So I know that I'm going to have, let's go do our lateral area first. So I'm going to have 2 times pi times 3, because that's my radius, times the height of my cylinder is 9. That's that width of that rectangle. And then we're going to add 2 times pi times my radius squared. And so I'm going to do 3 squared. Now I love, some of you have been writing out and typing out and putting all of your work, and I absolutely love that. So let's go do that. So 9 times 3 is 27 times 2, so this is part A, okay, is 54 pi plus 3 times, squared is 9, so 3 times 3 is 9, times 2 makes an 18, and so we end up having 54 pi plus 18 pi. So let's go type that into our calculator. We end up with 226.19, okay? And we're doing area, and so this is feet squared. Volume, remember, is cubic. Length, width, and height. Area is just squared. So this answer, if we go to the nearest tenth, 226.2 square feet. Okay, let's go do part B and see what we get. So same thing, we're going to do 2 pi RH plus 2 pi r squared. I need a radius, and it looks like in this picture I have a diameter, so make sure that you divide by 2 and that you use a 7. Okay, so we're going to do 2 pi times 7 times 10 plus 2 pi times 7 squared. Okay, so part B is going to give us, let's see, 14 times 10 is 140 pi. 7 squared is 49. 49 times 2 is 98. So we have a 98 pi. And when I type that all into my calculadore, I get 747.699. Let's go round to the nearest tenth. And so 747.7 square centimeters it looks like. All right, so I started to read number 2 and realized that the easiest thing to do is to draw a picture. And you'll notice I started to do that. So it says a circular fence that is 2 feet high. So here I've got a fence and it's 2 feet high. It's going to be built around the outside of a carousel. So on the inside, I have this carousel. Okay, a carousel. So isn't that the one where you ride the horses and you go around and around? I get dizzy on those. So it says the distance from the center of the carousel to the edge of the fence is going to be 35 feet. So from the center out is going to be 35. So it looks like that's our radius. And then it says, what is the area of the fencing that is needed? And so there's going to be this fence, and it's going to go around this carousel, okay? So let's go figure out, right, 2 pi RH. Now, why do I only need 2 pi RH? How come I don't need the top or the bottom? Yeah, so I'm hoping that you just said or thought, right, that we are finding the area of the fence around the carousel. We're not going to put a lid on it, and we're not going to put a bottom to it. We're just doing the part that is around, okay? So let's see what these word problems look like down here. So let's go take a look. Letter C says, find the area of the label of a can of tuna. And so just the label. So imagine this is a can of tuna. It's pretty tall for a can of tuna, but we just want the area of the label. And so we're just going to find the lateral area. Okay. And so for part C, we're just going to do 2 pi RH. All right, so let's see what we have. We have a radius of 5.1. So I've got 2 pi times 5.1 and a height of 2.9, and it's just a matter of typing it into your calculator. All right, and so when you get done, you type it into the calculator, you should get a 92.9. Let's go take a look at Got It problem letter D. We are finding the total surface area. And so for this one, you have to do the whole thing. And they want a candle. Some of you sent me some pictures of a candle yesterday. You have to be really careful. Make sure that you read really carefully. This says that the diameter is 4. And so notice you have to divide by 2. And then I just plugged it all into the formula, typed it into my calculator. Let's see, 2 times 2.5 is going to give me a 5 times 2 is 10 pi. 2 squared is 4 times 2 is 8. And so 10 pi and 8 pi is going to make a total of 18 pi, which is 56.5 square inches. Okay? All right, I'm hoping that those examples helped you out a little bit today. What you're going to do is you're going to pause your screen, go do the guided practice. I want you to check your answers when you're done. I'll let you know what your homework assignment is. All right, so I wanted to do a quick check with you, make sure that you're typing things into your calculator okay. When you do number 1, it should be pretty self-explanatory. Number 2, however, was given a diameter, and so you have to divide by 2 to get the radius. One of the things that can get confusing with this particular formula is which number you're actually squaring. So make sure that you're always squaring the radius, okay? It's always the radius that goes in that second part. So just be really careful with it, okay? All right, and number 5 is exactly what I mean. So with number 5, we're finding a total surface area. So I went ahead and wrote the entire formula down, but it says that the diameter is 10 meters. And so you have to be careful. Make sure that you're doing 5 squared, okay? 5 squared is 25 times 2 is a 50. 5 times 10 times 2 is a 100. And so if you ended up doing a 10 here instead of a 5, you would end up with 200 pi, and that's not going to be right. So you just have to be really, really careful which one that you're squaring. All right, let's go check number 6 and 7. The directions this time say to find the lateral area. So make sure you're only doing the lateral area part. All right, so just doing the lateral area, 2 pi RH, you should end up with 2 pi times 3.1. Do you know where the 3.1 came from? Times 6.8, and then 2 pi RH for the other one. And I just wanted to talk to you really quickly. This 0.99, when you round to the nearest tenth, it's going to make this bump up, which is going to make that bump up. And so it does end up being 377. All right, go try number 8. All right, and last but not least, number 8, we're finding the area of the label. So remember, the area of the label is just the lateral area. And so we're just using this piece of the formula, okay? But this is a cylindrical potato chip container, totally Pringles cans, right? Once you pop, you can't stop, okay? And so just, again, make sure you're using the right formula, typing things into your calculator, okay? All right, nice. So here's what I want you to do. Let's go try page 623, so the next page. Okay, do what you've always been doing. You guys are doing a fantastic job. Okay, let's skip this page and let's do page 625. And then I think that's it. So just page 623 and 625. Again, you guys are doing a fantastic job. So proud.